Amoli. Amoli? Nobody from Indonesia? Anybody from Indonesia? Do you say good morning in a different way? I have several announcements this morning. For early exams, some of you have asked me, you had very good reasons. So on December 11th, Tomalyn Lee. Is Tomalyn Lee here? No noise? All right. Well, I hope she remembers. And then a late exam, Jay Dong will have one on the 13th, but at 4 o'clock. Is Jay Dong here? No? All right. We hope they're studying hard. Then with regard to 131A, we have 131A. How many of you are in 131A? Quite a few of you. Great. We have that today with a neuropathologist, but we also have it next Friday. That's scheduled, and you've got a neurologist who's going to speak, and he is first class. And I hope all of you who are in 131A will please come next Friday, same class, same time. All right? Great. Let's see if there are any others. No, I guess that allows us to get started. How many of you have already studied the male reproductive system? Ooh, anybody want to give the lecture then? You'll try? No. All right, let's start then. So we'll start with the male reproductive system. And the primary sexual organ will be the gonad. Gonad is the testis. That's singular, testes, plural. So we'll be studying that quite a bit today. What is the function of the testis then? Everybody knows that. To produce sperm. And produce what else? Sure. Testosterone. What is the location? It's housed in a pouch of skin. Housed in pouch of skin. In the anterior, inferior, external, right? Follow it down. Anterior, inferior, external, abdominopelvic wall. Abdominopelvic wall. Within the pouch, there's a septum to separate right and left halves. One for each testis. Why does the testis have to be in this pouch? Because it's fussy. it wants it wants a cooler temperature. Aren't you glad all the rest of your organs don't want a cooler temperature or have their own temperature? But the testis does. So it's in the pouch because what's the normal temperature? 98.6, right? For the testis, it wants 95.6. So it wants cooler by 3 degrees. Don't you sometimes wonder how evolution finds these things? Now, if it wants to get warm, what does it do? It goes up. That's why you have your cremasteric muscle. Remember it? From the superficial reflex for an upper motor neuron lesion. So we have a cremasteric muscle. Will draw the testis up to body wall. We'll put to keep warm. But also serves as reflex, as superficial reflex. When you're testing an upper motor neuron lesion. So now, what's the size of the testis? This will be average, 1.5 inches in length and 1 inch in width. But there's tremendous variation, great variation in size. So now, what's going to determine the source of the initial sperm? Remember the source for the ova? What was it? The yolk sac. Well, it's the same for the sperm. So there'll be about 1,200, I don't know how they get the figures, 1,200 initial, what will we call them? Stem cells. Will migrate. These are from the yolk sac, as you said. Let me put it there. Yolk sac. Will migrate to the area where the testis will form. We were taught that was the genital ridge, but you don't see that anymore. But just to let you know, it did have a name at one time. So now we're ready to look at the structure of the testis, how it's designed to carry out its unique function for a lifetime. Structure. First, it's going to have a fibrous capsule. With partitions in it. In a few. In fact, there are hundreds of them. And these form lobules. And within the lobules are what? Seminiferous tubules. Sort of put them in. Seminiferous tubules. The literature varies on how many in a lobule, so I'll just collectively say 1 to 4. Some books say 2 to 3, some say 1 to 4, but 1 to 4 per lobule. And these seminiferous tubules are the source of spermatogenesis, the development of sperm. Source of spermatogenesis. Spermatogenesis. Formation of sperm. So there are many steps in getting from the initial stem cell to the sperm. So if we take a cross section through our seminiferous tubule, we're going to be developing the stages of sperm formation, spermatogenesis. This will be the basal membrane. And we put a hypothetical lumen. So we're going to follow the development from the basal membrane. The 1 to 4 here will be the germinal epithelium. Germinal epithelium. And we'll start with the cell closest to the outer membrane, the spermatogonium. Spermatogonium. This will be the stem cell. It will differentiate, go on, to form the spermatocyte. And there'll be different stages of spermatocytes. So we could say 1, 2, then 4 will be a spermatid. Spermatid, I think, is what it is. Not spermatid, a spermatid. And from the spermatid, we'll go to the sperm. So for every sperm, all millions of them, they start out through this progressive program within your seminiferous tubule. Now, what does a sperm look like? You ever seen one? Anybody seen a sperm? Yeah? Structure of sperm. So it's going to have a head. We'll have a hat, an acrosome, a body, and what's left? The tail. So let's start with the acrosome. Since it's getting close to Christmas, I like to put a red hat on. So our acrosome has enzymes to penetrate the ovum, to get this head into the ovum. The head has 23 chromosomes carrying the genetic material. All in the head. The body has sort of coiled mitochondria. And that's to provide energy to the tail so that it can move. Provide energy for tail movement. And so obviously we know what the tail is for. Movement. How anxious is that sperm to get to that egg? Do you know how fast it travels? Pardon? 3 millimeters an hour. 3 millimeters per hour. So I just add in parentheses, not so swift. I once had a cousin, and he was always saying, it's not so swift. And so this seemed appropriate for this action here. So now, just want to be sure always. Other kinds of cells here. And I want to say this is going on for a lifetime, again, as I keep saying, because the female has such a more limited time for her production of ova. So other cells in the testis. We have the sustentacular cells. Sustentacular. Sustentacular. What's another name for sustentacular? Sertoli cells. After Mr. Sertoli. So these cells will extend from the basal membrane to the lumen. With the membranes of the developing stages of the sperm embedded in the membrane of the Sertoli cell. Membrane of developing sperm. In the side of Sertoli cell. And so you'll have many of these. Why do you have Sertoli cells? What are their functions? One, they create the testis blood barrier. Create testis blood barrier. What other tissue in your body has a blood barrier? Brain. These are the major two. So why do we have one here? To prevent proteins discharge from the developing sperm to get into the bloodstream. Two, to regulate the amount of testosterone and estrogen that gets into or gets associated with these developing sperm. To regulate amount of testosterone and estrogen to influence developing sperm. To provide nutrients for the developing sperm. Provide nutrients for developing sperm. And one more, I'm sure there are many, but just give you a general idea how important they are. They will phagocytize the material that the sperm cells get rid of as they're reducing down to a regular sperm. You know, they've got all this cytoplasm. So they phagocytize the cytoplasm off the developing sperm. Okay? Phagocytize. Cytoplasm from developing sperm. So you can see why they're big and important. What other kind of cells do we have in the testis? Pardon? Interstitial cells, right. Try to pull them up. The more you think of them, the more they'll be embedded. All right, interstitial cells. So these will be in the connective tissue between the seminiferous tubules. So they're in connective tissue between seminiferous tubules. So if we draw a cross-section, of seminiferous tubules, we'll see them all developing in the connective tissue between them. We'll see groups of cells. Interstitial. And what are they producing? That's right. Producing testosterone. So now let's just review the hormonal input to the testis. And we'll have two. We'll have FSH and LH. So when FSH acts on testis, what do we get? Pardon? I don't hear you. It's acting on the seminiferous tubules. So what are your seminiferous tubules doing? Producing sperm. And what else are they acting on? What else is in the seminiferous tubule? We just developed it. Sertoli cells. So it's acting on Sertoli cells. And then we have LH. What's LH acting on? Interstitial cells, right. Interstitial, why do I block? Interstitial. Is that right? Should be 3. Interstitial cells. And what do? Produce testosterone. But I want them to be doing something else, but we won't give it now. That'll come later. All right, what? Yes. Is that what, did I put that in wrong? It's acting on the seminiferous tubules in the testis, sorry. Yes, it's acting on the seminiferous tubules. Let's just do that. Right? For sperm and Sertoli cells. Sorry. I appreciate that. All right, now what are the functions of testosterone? Well, at puberty, have many body changes. One, hair distribution. Varies tremendously from individual to individual. 2, we've already mentioned it, it acts on the larynx, right? What's it doing there? Making your voice deeper. Deepens the voice. As we said, made it more threatening. As I listen to you, I don't think your voices are too threatening. Maybe it's not the right circumstance. What else is testosterone doing? Yes. I just want to see the ones that I gave. Yes, I knew. These are two that we haven't had yet. It acts on seminal vesicles. And the prostate gland. Prostate, not prostrate. There's no R there. Prostate glands. And what are we going to find they'll do for us? They're producing the semen. You ever stop and just think of all the things that are going on in your body at one time? Ever appreciate, really? So from these, we're going to go through the duct system. We've created our sperm, and now we've got to get them out so they can become functional. So we've got a series of ducts. Do I have my epididymis here? Ooh, is Glenn still here? No, Glenn? You have the epididymis up there? Would anybody loan us an epididymis? No, because she's got it. Terrific. Thank you. She surprised you, didn't she? All right, we're going to look at the duct system. Thanks a million. Pardon? Oh, he took the epididymis with him. Oh, but he sure got it tangled. I'll let you untangle while I continue. Sorry. All right. Well, we had our testis, and we had our tubules coming up. I'm not going to go through all the refined tubules that these will go into. These are our seminiferous tubules. But then they will make networks of tubings very fine. But the one I want to come into, we'll just put little tubes that all have names, but I don't think it lends to our functional factor here. All we want to do is convey sperm into this mass of tubing. I'm going to stretch it out here. It's much smaller, called the epididymis. Epi means what? What's didymus? All right, then I have something to teach you. It means testis in Greek. So this is upon the testis. Just your timing is perfect. It's measured to be 20 feet long. And Jill has been so kind as to unravel our epididymis for us, so you can see. Whoops. Still going. Still going. Can you imagine this in a tubular form piled up on top of your testis? 20 feet. What other organ in your body do you have 20 feet long? Which one? Small intestine, right. You remembered. But isn't that amazing? Thank you, Jill. No, Many students who've seen this on the web, they can't believe that the epididymis is this long, but it is. So we're going to take the sperm through the epididymis, and it has very special microvilli on its epithelium. On epithelium, which is simple columnar. And this provides nutrients to the sperm because they're in this, they have the capacity to stay in the epididymis for at least 20 days. So these provide nutrients. Days in passage. I wonder how they mark them. Don't you? So if somebody says, what does the epididymis do? You can say that it allows maturation and storage of the sperm. Maturation and storage of sperm. All right, now we're ready to go on to the next tube, which will be coming on here, but we'll continue on the next board. The next tube is called the vas deferens. Vas for vessel, deferens for carrying away, carry away. This tube's major characteristic will be the amount of smooth muscle in its wall. You have no doubt when you're dissecting which tube in this area is the vas deferens. So it has large amounts of smooth muscle. In the wall. So when you see it histologically, I mean, you'll see the lumen like a regular lumen, but you'll see all this massive, smooth muscle around it. It plays a role in ejaculation. This tube, in contrast to the epididymis, is only about 18 inches long. Oh my. Let me just carry on and finish this because it's important. As it comes in, it's got to leave the external aspect of the body, take advantage of the inguinal canal, and get back into the pelvic cavity. So we'll do this with it. Take it from here. Give it its 18 inches. And now it's going to go through the inguinal canal. as part of the spermatic cord, which just includes the vas deferens, the blood vessels, and the nerves. And it will come now, but introduce new terms here. We're going to look at the posterior surface of the urinary bladder. This posterior urinary bladder. And this is urethra. And we're going to have two glands to introduce. We're going to have the seminal vesicles on the posterior surface, and their ducts. Two sets of them here. Seminal, as we said, they create semen, seminal vesicles. And we're going to introduce the prostate. We've seen where it is previously. Here's our prostate gland. So these tubules coming down, the ducts from the seminal vesicles, will come down and meet with the vas deferens. Can you hear me? This thing's come off. Do we have my friend Glenn? We have Jill. Thank you. That feels good. Thank you. So this is the duct from seminal vesicles. Meet with this duct to form which duct? Do you know? The ejaculatory duct. The ejaculatory duct. And it's the ejaculatory ducts that bring the sperm into the urethra. So in green, we have ejaculatory duct. Ejaculatory duct. So now you can see the importance of the internal sphincter, can't you? You see where it's coming in. The internal sphincter then, another color here. No, I don't, out of it. The internal sphincter was here, at the base of the bladder, at the beginning of the urethra. So this was our internal sphincter. So during ejaculation then, we want contraction of our internal sphincter so you don't urinate, so that the sperm have a free way down the urethra. We'll show a couple of slides. We don't have many. Here we have a beautiful slide of the seminiferous tubule. Can't hear me? No, it just fell off. I'll hold it. Can you hear me now? Okay. You see what the advantage of holding it is? So that we have the spermatogonia down here, and they're going to be changing as they're migrating up into spermatocytes and spermatids, and then we finally have the sperm in the lumen. But this is all germinal epithelium in the seminiferous tubules. In the next one, It's another one, but it's showing this time a Sertoli cell. It's rare that you can get a photograph of a Sertoli cell. These little sperm are all embedded in this Sertoli cell. In the next one, and this one, aha, do you see what I see? We stained it specifically for you. Aren't they nice? Those little acrosomes filled, but without them, we wouldn't have fertilization. Next one. And this is the epididymis. Here are all these, they look like cilia, but they've changed their names to microvilli, bringing nutrients to the sperm as they're coming through the epididymis. Tall, beautiful columnar cells. Next one. And this is a cross-section of the vas deferens with its wall. Do you believe me? I'm not sure I believe myself. What do you think it looks like it should be? We know they're not seminiferous tubules. They're definitely not with Sertoli cells. But maybe these could be little ones before they've developed their coat. Let's take the next one. Now this is definitely the vas deferens. This is all smooth muscle in different shapes. This is cut. This was longitudinal. This is circular. So there's no doubt about it. I'll check what the other one was. In the next one, that's it. All right. So have a lovely weekend.